Jai Hind everyone. My name is Ashish Dixit. I am assistant professor in a computer science engineering department in AKGEC Engineering College. So friends, today's topic related to a data structure, basic concept of graph theory. So here we will discuss about what is the graph, what is the basic concepts of the graph. Okay, let's see. So here a graph can be defined as a group of vertices and edges that are used to connect these vertices is also called a graph. Suppose that, let's take one example, because the graph is also having two types, directed graph and undirected graph. Okay, but here main theme is a graph. Graph is a collection of vertex and edges. Okay, so we can say that the collection of vertices and edges is called a graph. So here we will denote the graph through the G and vertices from a V and edges from a E. Okay, so let's start. So here this is the undirected graph, and A, B, C, D, E, these are all vertices. These are all vertices. Okay, and A to B is the edges, A to D is a edge, D to B is a edge, D to E is a edge, and E to C is a edge, and B to C is a edge. Means we can say that this graph is a collection of vertices and edges. Okay, just one. Okay, suppose that this is the, okay, suppose that this is the graph. This is the graph. This is the graph. Okay, and these are the vertices V1, V2, V3, V4 and V5, and these are the edges. What is the edges? One edge is connected to with two vertex. Okay, one is connected to two vertex. Minimum one edge will be connected to two vertex. So here this is the edge E, this is the edge E, E2, E1, E3, E4, E5, E6. Okay, means here we can say that these are vertex. A, B, C, D, E are vertex, and E1, E2, E3, E4, E5, E6 are edges. So here we can say that graph is a collection of vertices and edges. Okay, so here we are also taking our examples. This is a graph. A graph G can be defined as an ordered offset G, V, comma E, where VG is a vertex of graph, represent a set of vertices, and EG is a representative of the set of edges which are used to connect these vertices. Means through the edges we connect two vertices. One edge will be connect two vertices. Okay, so here a graph GVE with 5 vertices A, B, C, D and E. If you want to connect these vertices, then here will be declared through the edge. AB is a edge 1, BC is a edge 2, AD is a edge 3, and DE is a edge 5, and CE or a EC is a edge 6. Okay, a directed and undirected graph. So here we will discuss about the two types of graph, directed graph and undirected graph. What is a directed graph and what is an undirected graph? If we have any graph that have also consider a direction based edges is called a directed graph. Undirected graph, where we cannot declare any direction of the graph, is called undirected graph. Okay, let's suppose that a graph can be directed or undirected. However, in an undirected graph, edges are not associated with the direction with them, and undirected graph is shown in the above figure since its edges are not attached with any of the direction. In any edges exist between vertex A and B, then vertices can be traversed from B to A and A to B. If you are not given a direction, then we will consider a both side. Suppose that here is a consider C to E. This is the direction. This is the direction. Okay, just 1 minute. This is the undirected graph, and next is a directed graph. A directed and undirected graph. A graph can be directed or undirected. Here we are also mention a directed graph because here also direction will be given A to B, B to C, C to E, E to D and D to A. These are directions. Okay. Then in a directed graph, edges from an order pair, edges represent a specific path from the some vertex A to another vertex B. Node A is called initial node, while node B is called a terminal node. A directed graph is shown in the following these types of the figure. This is the directed graph. Okay. So here we will discuss about the basic terminology of the path. A path can be defined as a sequence of nodes that are followed in order to reach from terminal node V from an initial node to U. Suppose that this is the vertex A and this is the vertex B. This is the vertex C. A to B, B to C. What is the path from A to C? Path from A to C is A to B and B to C. This is the path. A path can be defined as the sequence of nodes that are followed in order to reach some terminal node V from the initial node U. Here A is a initial node and C is a terminal node. Okay. So next, what is the closed path? A path will be called as a closed path if initial node is same as a terminal node. Suppose that we will start a path from A, okay, then from A to B, then B to C, and then C to A. This is the initial path, and after the visit, this is the terminal node. This is the initial vertex and this is the terminal vertex. Means both initial and terminal vertex will be same. Then this concept is called क्लोज्ड पाथ. मीन्स जिस नोड से आप स्टार्ट हुए हैं लास्ट में उसी नोड तक अगर आप पहुंच रहे हैं देन दिस इज कॉल्ड द क्लोज्ड पाथ. ओके, गॉट इट. नेक्स्ट, अ सिंपल पाथ. Simple path means you can say that a ordinary graph that is also considered from an initial vertex to terminal vertex. Means if all nodes of the graph are distinct with an exception v0 is equals to v1, then such that path is called as a closed simple path. Exception means we cannot consider a closed path. Cycle path. A cycle can be defined as a path which has no repeated edge or vertices except the first and last vertices. Always kept in mind. means vertices will be not repeat except then first and last. Okay, suppose that A, B, C, D. This is a cycle आपके पास, means A to B, B to C, C to D and D to cycle. But if you again reach, then this is the closed path. So here we will spell this concept. Then A to B, B to C, and C to D. This is the cycle of the concept. Okay. A cycle can be defined as the path which has no repeated edges or vertices except then first and last. Means first and last आपकी repeat हो सकती है, but सभी जो उसके डायरेक्शन में आएंगी ये नेसेसरी नहीं है कि वो सभी रिपीट हो. मीन्स लास्ट, फर्स्ट एंड लास्ट में भी रिपीट हो सकती हैं. ओके, नेक्स्ट, व्हाट इज अ कंप्लीट ग्राफ? अ ग्राफ, कंप्लीट ग्राफ इज अ वन इन विच every node is connected with all other nodes. A complete graph contains n into n minus 1 by 2, where n is the number of node in the graph. Okay, a complete graph is the one in which every node is connected with all other node. Got it? Means a complete graph is a one in which every node is connected with all other nodes. A complete graph contains n into n minus 1 by 2 edges, where n is the number of nodes in the graph. Weighted graph. Next, a weighted graph, each edge is assigned with some data such as length or weight. Suppose that A to B, this is A vertex, this is B. Both vertex connected by the edges, and here this even edge have the value of 4. Okay, we can say that the length of the edge, or we can say that weight of the edge. This concept is called a weighted graph. एक ऐसा ग्राफ जहां पर सभी एजेस वर्टेक्स से कनेक्ट हो रही हैं और उन सभी एजेस की कोई ना कोई वैल्यू दी जाए. दिस इज कॉल्ड अ वेटेड ग्राफ. अ diagraph is a directed graph in which each edge of the graph is associated with some direction, and the traversing can be done only in the specific direction. Means we will given a specific direction we will provide. लूप, जहां से वर्टेक्स शुरू है उसी पर ही अगर कोई रूप आ जाता है उसे बोला जाता है लूप. जैसे अगर सपोज दैट मैंने इस तरह से इसको किया है और यहां पे ही मैंने एक एज इस तरह से मूव करा दी, देन दिस इज कॉल्ड द लूप. एन एजेस दैट इज एसोसिएटेड विद द सिमिलर एंड points can be called as a loop. Okay, adjacent nodes. If two nodes will be connected with each other, then this is called a edges. But suppose that A to B, B to C and C to A. A याद रखिए, A किससे एडजेसेंट है? B से. B किससे एडजेसेंट है? C से. एंड C किससे एडजेसेंट है? A से. यानी जब कभी भी एक नोड, दो नोड, तीन नोड एक दूसरे से कनेक्ट होते हैं, कनेक्शन को ही हम बोलते हैं एडजेसेंट. इफ टू नोड्स U and V are connected by an edges C, then nodes U and V are called the neighbor or a adjacent node. Degree of the node. Suppose that this is the B vertex. B वर्टेक्स से दो एजेस जा रही हैं, then the degree of B is 2. मीन्स किसी भी नोड से जितनी भी एजेस पास होंगी, नंबर ऑफ काउंटिंग द नंबर ऑफ एजेस ऑन दिस वर्टेक्स is called the degree of these vertex. Okay, a degree of a node is a number of edges that are connected with the node. A node with degree 0 is called as a isolated node. अगर कोई भी नोड है और उससे कोई भी एजेस होके नहीं जा रही है तो उसको कहा जाएगा दिस इज द आइसोलेटेड नोड. ऑलराइट, a graph representation. So here we will discuss about the graph representation. Then first point is a sequential representation. A sequential representation, how to represent a sequential representation. So here we are also taking a graph, undirected graph A, B, C, D, E, and through the undirected graph we will maintain adjacency matrix. Okay, so we can say that in a sequential representation we use adjacency matrix to store the mapping represented by vertices and edges. In an adjacency matrix, the row and column are represented by the graph vertices. A graph having n vertices will have a dimensions n cross n. Okay, and entry Mij means matrix, and also mention I comma j row and column matrix. Okay, Mij means row and column. In adjacency matrix representation of an undirected graph, G will be 1 if there exists an edge between Vi to Vj. An undirected graph and its adjacency matrix representation is shown through this figure. Suppose that here we will make a adjacency matrix. A, B, C, D, E are a vertex, then A, B, C, D are a vertex. Through this we will maintain adjacency matrix. Again A to A value 0 because A से A कोई भी कनेक्शन नहीं है, कोई भी adjacent vertex adjacent vertex नहीं है. ओके, देन A to B क्या है वैल्यू 1. जो भी वर्टेक्स कनेक्टेड हो एडजेसेंट हो उसको हम 1 कंसीडर करेंगे और अगर नहीं है तो उसको हम 0 कंसीडर करेंगे. ओके, A to B, A to A 0, A to B 1, A to C कोई भी कनेक्शन नहीं है 0, A to D कनेक्शन है 1 और A to E कनेक्शन नहीं है देन 0. अगेन B to A ऑलरेडी है कनेक्शन, देन B to C 0, B to B 0, B to C 1 and B to D 1 and B to E 0. Again C to A 0, C to B 1, C to C 0 and C to D 0 and C to E 1. Means always kept in mind, if both vertex will be connected through the edges, then this will be considered a 1. Otherwise we will consider 0. Then again D to A 1, D to B 1, D to C 0, D to D 0 and D to E 1. Then E to A 0, E to B 0, E to C 1, E to D 1 and E to E 0. Okay. Then similar way we will consider a directed graph, but through the directed graph we will also taken through the direction. If direction is given from one node to another node, then this will be considered a 1. Otherwise it will be considered a 0. Again A to B, B to C, C to E, E to D, D to A and B to A. Again maintain adjacency matrix through the directed graph. A, B, C, D E, A, B, C, D, E. A to B 1, otherwise 0. Then B to C and B to D. B to C 1 and B to D 1, all 0. Then C, C to E, C to E 1, all remaining 0. Then D, D to A 1, all remaining 0. And E, E to D 1, all remaining 0. Means we will create adjacency matrix of the directed graph. Got it? Again, how to create a linked representation, linked list representation of the undirected graph. Okay. So here we will create an adjacency list. Suppose that A to B, how to create a linked representation? How to create a linked list representation? Then here we will also declare A, B, C, D, E all. Then A to B is connected and B to and B किससे connect है? D से. Then B to D connected. But D किससे connect है? नहीं. B to D किससे connect है? देखिए A to B, then D to B to D, then D to X नहीं होना चाहिए. नेक्स्ट चलते हैं. B to A कनेक्शन है, then A to D, B to A, then A to D and D to C. है क्या? नहीं है. नेक्स्ट C to B कनेक्शन है, then B to E क्या कनेक्शन है? नहीं. नेक्स्ट D to A connected, then A to B connected, then B to E connected. Okay. Then E to D connected, D to C connection है ही नहीं. Okay. So here we can consider linked list representation, and adjacency list is used to store the graph into compute the memory. Consider the undirected graph shown in the following figure and check the adjacency list representation. Through this, an adjacency list is maintained for each node present in the graph, which store the node value and a pointer to the next adjacent node to the respective node if all the adjacent nodes are traversed. Okay. Then store the null in the pointer field, the last node of the list. Then sum of the length of the adjacency list is equal to the twice of the number edges present in the undirected graph. Then this is the procedure of the directed graph. A to B, then next B to C and C to D. Next C to E, then D to E, then E to D. These are a adjacency list. In a directed graph, the sum of the length of all adjacency list is equal to the number of edges present in the graph. Then this is the adjacency list of the weighted graph. A to B, B to C, B to D, D to E, then A to B 5, then again B to C 2 and C to D and C to D. देखिए C to D कैसे जा रहा है? C to D, okay, C to D and then इधर आते हैं, then इधर आते हैं. तो आप देखिए कंसीडर कितना हो रहा है. Then next C to E 4 डायरेक्ट की बात कर रहे हैं. Then D to A 7, then E to D 10. Okay, thank you. These are the main basic concepts of the graph theory. In our next lecture, we will discuss about the graph traverses, BFS and DFS. Okay. Thank you very much.